Hello guys, today I will teach you how to use multimeter or multitester. And what is multimeter? First, what is multimeter? Multimeter is a measurement of component where voltage, current, and resistance, where it is good or not. So there are two types of multimeter. Analog multimeter and digital multimeter. In analog multimeter, there are needle and the scale where to measure the component, and this is adjustment for the needle to correct the exact position, and this is the ohms adjuster to adjust on exact and a correct position at the correct 0 point of the resistance. So I will show you later, and there is a range and the range adjuster and two test probes, such as a positive test probe and negative test probe. This one is not commonly used for this type of multimeter, so we will skip this part. So this is the common use for the tester. So in digital mode, is digit show as a digit and has a light and hold the measurement. I will show you later. And range and the test and the range selector, and two test probe, same as analog, and this one is for current, to test the current, such as maximum of 10 amp, while in this analog the maximum of the current tester is 250 milliamp only. So first, what is this scale at the top is measure the ohms. So first, how to measure the resistance? Here is the ohms, such as resistance. So we select here from times 1, meaning times 1, we read such as 1, 2, 1, 2, 3, 4, 5, 10, 20 ohms, 30 ohms, 50 ohms, 100 ohms, 200 ohms, 500 ohms, and so on. So here from times 1, we should read in this scale from 1 ohms, 2 ohms, 3 ohms, 5, 10, 20, 30, 50, 100, and so on. Where if we put this at the times 10, we should times 10 the number in this scale. Example, if the pointers or needle put in the 5 ohms, so we will times in this range. So 5 times 10 goes to 50 ohms, so equivalent to 50 ohms when the needle in here. So if we put this at 100 times 100, so we will just times if the needle point any of this scale. Like example, if the pointer is at 10, so we will times it 100. So 10 times 100 equals to 1000 ohms or 1k ohms. So and so on. So we will show you later. I will show you example. This is the resistor. The color code of this resistor is 1k ohms. So first we should know the value of the resistor so that we can test if it is good or not. So how will know if it's good? If the resistor is good, well the value is the same in the tester. So I will show you. So this is the 1k ohms. So we will put, so we can see here is we will put the tester is greater than 1k ohm. So we will see, we can see here there are from 1 to 1k and 2k. So we can say that 2k is so small, we can say, well, we cannot see. So we will put in times 10. So we can see the times 10, we can see at 100, or we can times 100 so that we can see the needle at this point, because 10 times 100 is equivalent to 1k ohm. So here we go. The resistor is this is the test probe of the two. So in resistor there are no polarity. We can put the two test probe wherever in these two. So let's test. As you can see, oh no, first we will, if you are testing resistance, we will short first these two probe to make it at 0 point. So this is the ohms adjuster. So we will adjust at exact 0 every time you put this. Example, if you change the range, so we will short again to make it at 0, to make it sure at 0 point. So this is the correct. So example, we put at 1k. We will test this resistor. So you can see it is at 1 at number 1. So we can see here there 1 times 1k, so equivalent to 1 kilo ohm. So if you can see clear, we put this at 100, so that 100 times 10 is equivalent to 1k ohm. If it is at 10 ohms, so we can see the test is correct, is at 10. So 10 times 100 equivalent to 1k. So meaning this resistor is okay. If it is not at exact 1k ohm, the resistor is not good. We will change it. So we will test in digital. We can see here the ohms. This is the beep sound. It's belong also in ohms. So this only we test the continuity and beep sound. So only we see here 200 2k 200k 2 mega 20 mega. So at this point we know that this is 1k ohms. So we will put at higher than 1k ohms so that we can see here. So this is the OL, meaning there is no continuity or open line. If we short, we can see the voltage. So at exact 0 if we short it. So in this digital we will not do same as this, like we will short the two probe. So we will understand that is the at ohms, so we will put at 2k, so we will measure it. And also the no polarity we can change, so we will see here 0.99 or k, so or 1k. So we can also change the polarity, and also the same, there's no polarity at this component when we measure the ohms. So that's it. We can also adjust here, so we can see here 1k also the same. So it's more accurate when you test at the close to this, but higher. We should put at higher than this value. So this is the ohms. Next, we will test this DC. So we can see here 0.1, 0.5, 2.5 volts, 10 volts, 50 volts, 250, 1000. So this is the DC voltage and AC voltage. So first, in a DC voltage, we will test the component, or like this, the battery is a DC. So how we will know if it's good or not? So we can see this battery is not good anymore, so we will test if it's good or not. So we can see the value of this battery is 1.5 volts. So we will test in this part. We will put the test probe at the correct polarity. There is a polarity, this is a positive and this is a negative. So we can see in this test probe is positive and this is the negative. So we will put, as you can see, it is 1.5, so we will put the range at higher than the battery. So we can measure, so at this point 2.5, this is the range in the scale. 250 is equivalent to 2.50. We will assume this is a 2.50 because of this point. So if we put at 10, so this is the measurement. If we put at 50, this is it. So if 250, we will back in here 250. So if 1000, we will assume this 10 as a 1000. So okay, let's test. We will put only at 2 because this is only 1.5 volts. So let's test. I put this, and here, as you can see this needle is at 100. So 100, or this is a 2.52. We assume this is 2.50 because of the range 2.50 to 1.5 and 100. So the needle is at this point 100, at 100, or it is 1 volt. So this battery is only 1 volt, so this is not 100% good. So we can see here, this is a battery test. We can see if it's good or not bad. So we will adjust this at 1 point. So we can see here the 1.5 volts and 9 volts. So we will test at 1.5. We can only use this for 1.5 and 9 volts. So let's test. So you can see here is at the middle, so it's a between of bad and good. So we cannot, this is not good, not a 100% good. So we will show you how to test this good battery. This is a 9 volts. So first we will put, I will show you, this is 9 volts. So I will range the test probe at DC because this battery 9 volts. So we will put this at 10. So this is the measurement 10, 8 to 0. So we will test. I will put here. So we can see the positive is this and the negative this. So we'll put the correct probe. Okay, negative and positive. So the value is close to 10, so it is mean at 9. So we will change this range to make it clear to us. So we'll put at 50. So we can see here 50. This is the range where we'll see the measurement of the battery. So 50, 40. So we'll put again here. So 50, 40 is at 10, close to 10. So meaning this is good battery at 9. You can see here, this is the 9, this is the 10. So you can see here. So if you are not really sure, we will use digital here. This is the DC. As you can see, the sign is straight. DC is means direct current, and this is the AC, alternating current. So we will use this digital. So the same as here, we will range the voltage at higher than this. We can see here the range is 220, 200 volts, 600 volts. So we will put it at 20 volts because this is a 9 volt. So as you can see, we will test. We'll put the positive here and the negative. No, this is the test probe of this digital. So sorry. Okay, I will show you it. Positive and negative. So you can see directly 9.83 volts. So this is good, close to 9. It's also same. So that's it. So we can use this button as light, and if you double click, we can see there's a flashlight there. So this is the hold button. so that we can see the measurement even we remove this probe. So that's it. So if it's higher than 9 volts, we should, example, if the battery is 30 to 20 volts, so we will put it at 200 to make it sure. So if the battery is 20 volts, we will put at higher than 20 volts to make it safe. Okay, so after so I show you already the resistance and the DC volt. AC volt is used for the outlet or such or anything that that are AC voltage. So we have no the example for you. So you will use this same as DC. So if the component you measure is AC, so you put here example the outlet in our area is 220 volts. So every outlet is not fixed or exact 220 volts. So other is in our country is 220, sometimes is 250 or in between. So if that is the case of exact voltage, so we will put this range at 1000 to make it safe, so that we cannot damage the multimeter or multitester. So some of AC there is no polarity because the voltage is changing, as you can see, alternating current voltage, so it is changing, so we can put this at any direction. So that's it. So same in here, there's a digital in digital you can see AC same. So the range is 600, 200. This is a measurement from another test point. Every digital there's not the same measurement or range. Some other analog digital there is autorange like this. So in this type of digital there's not autorange because you can select if it's at 220 at any range here. So this is same if the AC voltage we will measure is 250 volts, so we will put higher than that so that our tester is secured and will not damage. So that's it. So we will back here. So if we measure, this is the current, so at this point we can only measure from 500 microamp to 250 milliamp. This is the maximum of amp or current we can measure. So if it's greater than that, if we put at the low, this fuse will damage, only fuse will damage, so we can change it inside this multimeter if it is damaged. So this is the highest current. So in this part, if you are in this part, the current is from 200 milliamp, 20 amp, 200 milliamp to 10 amp. So we can see here, if this is at this point, the fuse is at exactly 200 milliamp, the maximum of voltage of current we can measure, 200 milliamp. If we are measuring like 1 amp to 10 amp, so we can't use this because it's only 200 milliamp. So we will change this probe to, okay, wait, sorry, it's hard to remove. Sorry. Sorry, I can't show you in fix. So we will just change this probe here so that we can measure the 1 amp or high or 1 amp to 10. So if 10 volt, 10 current, so it's okay, we can use this. So don't use if it's greater than 10, it will damage. So that's it. Okay guys, thank you for watching. Hope you learned something.